All right, we're going to get started on this Illinois Energy Now webinar presentation recording of the school energy walkthrough. It's a short technical webinar on school energy use and what types of energy using equipment you might see in a school building and what kind of incentives are available for that. My name is Andy Robinson. I'm the Training and Education Director here at CNEC, the Smart Energy Design and Assistance Center in Champaign, Illinois. I need to advance my next slide. All right. The Illinois Energy Now program, which CDEC is a part of, is a part of the Illinois Department of Commerce. Illinois Energy Now program includes the Energy Resources Center at UIC in Chicago, the Midwest Energy Efficiency Alliance, and CDEC, which is a partnership between the public university at the University of Illinois in Champaign and the private side, which is the 360 Energy Group. And all told, we cover the whole state, cover the entire state with energy audits and energy assessments. Energy assistance. Our free services include outreach and training, energy assistance and assessments, new construction design assistance, new construction incentives, energy performance contracting support, retro commissioning, and application assistance. In today's webinar, we'll touch on this energy assessments and assistance, which is the bulk of what we do, and we won't touch too much on retro commissioning or the performance contracting or new construction, but we'll touch on it briefly. Just to mention a little bit about where the funding comes from. So the funds for our program are collected on everybody's electric and gas bill. So on the left here, we have the ComEd and Ameren electric portion, which is a energy efficiency rider on everyone's bills. So even though these are free services and incentives to save money on saving energy, everyone is paying into these programs on their bills currently. So 25% of the electric energy efficiency funds collected goes to the Department of Commerce for the Illinois Energy Now program. And likewise with the gas, 25% of the gas funds collected go towards the public sector program as well, which covers governments, K-12 schools, which we'll talk about today, community colleges, public universities. There's also a sister program for low-income residential, affordable housing, public housing. And CDEC covers all of these public clients. Now that leaves the residential and the business sector is under the ComEd programs, and the NICOR and People's programs are separate as well. Let me just pause this for one moment. Check the recording for a second. Great, everything's working well. Next, the Illinois Energy Now program has public sector gas and savings incentives that are being updated currently. Right now, projects with high gas savings, HINGE program, the High Impact Natural Gas Efficiency Program, incentives have gone up from $2.50 a therm to around to $3.50 a therm for if you're using or saving 50,000 therms annually, or if you're saving 100,000 therms annually with your project, $4.50 a therm. We'll talk about some of the size of the projects that you might need for this kind of savings. But there's also the boiler system projects, so boiler tune-ups, mechanical pipe insulation, steam trap assessment, repair, and just this week, just in, the boiler tune-ups for schools can be free. There's normally a 75% cap, but the cap has been removed, so it's possible that the entire incentive could be paid for. Incentive could pay for the entire project. I think it's up to $1,500 every 3 years. So this is the kind of program that people with large boilers are probably tuning up their boilers yearly. But if you haven't tuned up, and this is an incentive to help you, this is an incentive for you to do that, and you can take advantage of this program every 3 years. Questions for this program this is run out of the UIC campus at ERC in Chicago, and Brian Academy is the person to contact there. Their information is all on our CNEC website and on the Illinois Energy Now website. If you Google DCEO Energy, or if you Google CDAC, or if you Google Illinois Boiler Program, yeah, that'll get you there as well. And we'll talk a bit about, that's this slide here talks about these, another new promotion as of this week, which is that we're waiving the $300,000 building cap for all facilities. And although it's still preferable to not exceed $150,000 for grant reasons, but for each project. And number two here, the cap, if you're a school that's never been with, has never participated in any of these incentives, then you're eligible to waive the 75% cap on the custom and standard incentives as well. So you could get 100% of your project paid for, and that includes labor. So total project cost is equipment and labor. These are, so that's pretty excellent incentives. If you're unsure, if you're unsure about if you're eligible for this or any of the incentives, you can either contact the 800 number, which goes to the CDAC office, and we can field your questions. If you know that you have specific incentive questions, you can also contact Lisa Tubner here at illinois.energy@illinois.gov, and her phone number in Springfield is here as well. These are the standard incentives that I mentioned very briefly. Oops. Standard gas, standard electric incentives. So there's standard incentives for replacing lighting T12 to T8, $7 a fixture, reduced wattage T8, new interior lights can be 60 cents per reduced watt. And that can include LED fixtures. So 60 cents per reduced watt on LED fixtures as well. We'll talk about in a little bit about why that does not include T8, LED T8 retrofits, but new fixtures are just fine. And LED exit signs, lighting controls, HVAC side, air conditioning, pumps, fans, motors, demand control, ventilation, kitchen equipment. We'll touch on all these as we go, as we do our walkthrough momentarily here. Custom electric incentives are at 12 cents a kilowatt hour. So if you can do a simple calculation of what the savings will be if it's a 24/7 operation, something outside of the norm, or something that's not on this list, then a quick calculation can suffice to help justify the savings. CDAC audits, CDAC energy assessments will have these calculations in them as well. So if you need assistance, technical assistance, CDAC is available for that as well. Similar to the natural gas incentives, we've touched on some of this, the boiler incentives and the boiler tune-ups, and furnace incentives for replacing furnaces, looking at boiler reset controls, steam pipe insulation, steam trap maintenance, kitchen equipment, and exhaust hoods for kitchens. We'll touch on that. That's funny, the lights just went out on me. Pause this for a second. So that's an interesting example of occupancy sensors in a room, and why I prefer, well, I guess this is a vacancy sensor. It just doesn't happen to see me. So I'm gonna wave my arm a moment. There we go. All right. So occasionally occupancy sensors can trip you up, but if this room wasn't being used, because it's not my normal office, it would be good to have these lights going off automatically. So since we mentioned that, by the way, occupancy sensors were on the electric incentives. Lighting controls down here, vacancy sensor, $30 per sensor. So you want to make sure to have it on a good delay. It's probably, I probably have been sitting here for 5 minutes or 10 minutes. I would say that 20-minute delay might be better. Again, with natural gas custom incentives, $2.50 a therm is typical, or if you're in the very high natural gas savings program, $3 and $4.50 is possible. I wanted to briefly touch on the Illinois Energy Now STEP program, Savings Through Efficient Products. This is run by MIA, the Midwest Energy Efficiency Alliance, and this is a partner of the program. It's a little bit different than a CDAC assessment. They will come and do a site visit. It's just a brief visit, and they bring with them equipment, or they can send you equipment based on their site visit. They can give you free faucet aerators, free shower heads, free kitchen nozzles, free exit signs, free LED screw-in bulbs, vending machine controls, occupancy sensors for lights that we just talked about, the $30 occupancy sensor incentive. You can get it for free from MIA STEP program. Outdoor screw-in bulbs for free for LED. And so I highly recommend people look for this MIA program as well. If you're part of the CDEC program, we'll recommend that you go through, get a MIA audit as well, or MIA walkthrough, a step walkthrough. Or conversely, if you get a step walkthrough, you might want to, these would be the low-hanging fruit, the easily installable items, and then CDEC could help you identify more of the HVAC savings, more of the building integrated issues that you have with energy in your building. But I highly recommend checking out the IllinoisStep.org for these incentives and getting a MIA walkthrough audit. Briefly, a couple other MIA items here. They also have Lights for Learning for schools that are interested in educational curriculum around energy efficiency. We just talked about the STEP free energy savings products for self-install. If you have data centers in your school, if your district has a data center, there is a separate data centers program, specific program for that, working with a private partner, free assessments and engineering assistance to improve data centers, enormous energy savings there. And MIA runs building operator certification training, and many building operators go through that program each year. To talk about a little bit more about boiler tune-ups here, here are two examples. One from Ball Chatham. They tuned up 23 boilers throughout their district, and they received a $38,000 incentive, and it cost $45,000. If they were in the incentive right now, that might be 100% paid for. But this is probably that 75% cap, which is typical. But right now we have a special program. Therms save 10,000 therms, save $7,000 of savings. So that's a one-year payback on improving the efficiency of these boilers. So it's an excellent payback after incentives for these projects. And we have clients that do this every year. The incentive is only every 3 years, but depending on how your boilers are operating and what kind of tolerances you have on your air-to-fuel ratio and how recent that equipment and how new that equipment is, you certainly could do with a tune-up every 3 years at least. On the right here, we have Hillsborough Schools insulated pipes in 3 schools. They had uninsulated steam pipes, and which can present a safety hazard as well. The cost for this installation was $24,000, $25,000, and they received $19,000 in incentives, but they're saving $3,000 a year on this. So 2-year simple payback. So excellent simple payback on this project as well after incentives. And there's the safety aspect as well. So we've seen some districts that are going through with these kinds of projects in conjunction with a life safety program. So there are ways to get these projects done, and energy can be a portion of that, these energy incentives. I wanted to briefly just touch on how efficiency is working nationally. So this graph is a hopeful graph to me. It shows the 100 quadrillion BTU. So 100 quads of energy is our total US consumption of energy. So this is building sector, industrial sector, residential sector, and transportation sector all added together. And you can see the increase that we had in the 60s and in the 80s and 90s. And in the last 15 years or so, we've done a really good job. We skirted around 100 quads, but we dipped with recession, and then we've come back, and there's versions of this with GDP that show that the ratio is a really strong ratio, where our GDP increases, but our energy has been staying level. So that's excellent. This also shows total energy production. So this is natural gas fracking and oil drilling, and the number of imports dropping, but the number of exports increasing as well. So energy efficiency is working, which is excellent. Examples of equipment that we're going to touch on today: HVAC equipment, rooftop units, chillers, boilers, controls, steam traps, furnaces, lighting, and motors. In this list here, we have the top 10 strategies in a rough order of cost effectiveness, with the low-hanging fruit on top. So lighting and plug loads are the obvious items to do right away, the no-brainer items to implement. Plug loads, that could be turning computers off, could be getting rid of electric resistance heaters. A lot of times I like to say, well, maybe even, so getting rid of heaters, there's a safety risk and also energy cost, but maybe being flexible and allowing, say, heating pads. So a heating pad for a desk you can have in contact with your arms, and that can help you keep warm throughout the winter, and it uses 1/10 of the energy of an electric heater, and they usually turn off after 2 hours automatically anyways. Hopefully my lights don't turn off on me again. For heating, for HVAC, we have ventilation reduction, maybe heat recovery in areas that are 24/7 operation. Heating and cooling, like condensing boilers, we'll touch on in a few slides. Motors and pumps, variable frequency drives, turning the pumps down, turning them off when they're not in use. Building automation and commissioning, that's probably more than we have time for today, but important topics that for another technical webinar coming up. And building envelopes, so we're talking about air sealing a little bit, insulation and windows. Now these are expensive to do as retrofits, so they're usually sort of the last items to do. They're very capital intensive and they save energy, but the upfront cost, it's usually, again, you have to do something like a life safety aspect on some of these, especially on windows, for instance. They're very, very expensive. An extra credit for renewables, we like to say that once you've done efficiency, then planning for renewables makes sense. You could plan the infrastructure for now. You can get maybe a small solar array paid for through the Clean Energy Community Foundation. I think Illinois is number 3 with the number of schools that have small solar arrays, so that's excellent as far as an educational aspect. Down here is there's an array on a bus garage. They have 305 kilowatts on their bus garage. It's also an energy-intensive location, so I think this covers about 10% of their load annually. But it can be a really excellent thing to plan for in the future. We see people just now starting to look at power purchase agreements. Here's Holly Nelson. She worked with her church to put a 10 kilowatt array on. We've had some churches in the last 6 months, they're looking at doing power purchase agreements where they do leasing of these panels, long-term agreements with plans to buy, to purchase through the energy cost savings over time. Let's briefly touch on a success story for an elementary school here. This school replaced the existing boiler and the chiller. They added new windows. They replaced their windows, retrofit lighting, occupancy sensors in rooms, vacancy sensors, and addressed air sealing problems that they had. They, because they had so much air sealing issue in the school, they actually they had an excellent savings, $17,000 of savings, and the project was in the range of $140,000, so that's a 6-year payback, which is amazingly low, considering they put in expensive windows. Boilers and chillers are both expensive, but their energy savings each year was pretty excellent energy savings. And we're going to contrast that with another school in the same district in a minute that had a longer term payback. But let's touch on the air sealing though. Here's an image of that air sealing problem that they had. So before and after, and you see the gap here in the window, in the wall to roof area, and the spray foam that's sealed it up. We have some clients that this was a gut rehab that they were doing, so the ceilings are down and they had easy access. But we have clients that stick their head up in the ceiling tiles and see daylight coming through, maybe on one corner of the room or another. So getting spray foam and spraying those is a good first step, and not as thorough as doing the entire wall like this, but that's the kind of thing that reducing that air infiltration is a really big deal. And it's infiltration of insects and mice and spiders and crickets, so it's beneficial for many reasons. Now we're going to go to the second school in that district. This school did new geothermal system. They didn't have a cooling system to begin with, so they added air conditioning to this building. So that right there is going to raise their cost a lot. They have to have an entirely new system. Gosh, light sensor. Too short of a delay. But they added new windows. They retrofit the lighting, occupancy sensors in the rooms, and they for this report, I don't think the air sealing was completed yet, but they have an annual energy savings of $19,000. And it was a much more expensive system. So we're talking in the $600,000 range with this new geothermal system, this new cooling system that they have. But the school is now functional all year round. They don't have to get out early, and they don't have to release for heat weather days. So those savings are hard to compare to just energy savings alone when you're adding a completely new system. So this had a 29-year payback compared to the 6.5-year payback on the other school. But what this school district did is they're looking at the long haul. They've added a new system. This system is a geothermal system that should last for a long time. It's buried underground with access points, but it's not exposed to the elements, and it should be a nicely sealed system for the long term. And the other thing the school did was they did a performance contract where they combined this school and the other school together. So the school with quick payback and the school with longer payback, and an energy performance contract where the energy service company can come in and guarantee an estimated savings, so that the price to pay for these projects comes out of the savings for these projects. So you need to come up with the upfront bond. In this case, I think they had either a bond or a 1% sales tax. And but sometimes ESCOs will help finance the projects as well. And then the energy savings is estimated to help pay down the savings will pay for those projects over the long term. And that might be a 20-year project, 20-year payback or lifespan on paying for those projects. But a really excellent tool that the CDEC program has a consultant that helps review those contracts to watch out for any possible problems, to make sure everything's kosher with those contracts. And we've had excellent success with those in that program. All right, we have, here's an example of not those schools. This is a school in Southern Illinois that decided that they were far enough south that they didn't want to add continuous insulation to their walls. So they have wall cavity insulation, and the code requires continuous level of insulation. But either the designer said, well, there's not a code official in this area, or the construction company skipped some corners or something. But you can see the metal studs in this thermal image on the left, the metal studs just bleeding heat to the outside. So these cold areas are 64 degrees on this graphic, and it was about a 30-degree day outside. But just imagine being an occupant in this space. They had called us because they were complaining about their new building was cold. The people with their backs to the walls were chilly, and you know, it's not going to be easy to add insulation in this unless you're going to do a gut rehab. So one of our recommendations in this case was, well, maybe look at putting a heating pad on the backs of people's chairs in those particular offices. Or moving those people with people that are chronically warm, if possible. Likewise on the window here, the thermal image of the window shows that corner getting down to 41 degrees. So this is where we're below the dew point. That window is starting to collect water vapor, and it'll start condensing water and freezing if it gets too much cooler. So this is an aluminum frame that was not thermally broken, and that aluminum is just transmitting the heat right outside. Again, not an easy thing to fix after the fact. Quick example of this high school that we worked with in Northern Illinois. They were 2001 construction, pretty standard construction, constant volume system, which is part of a problem right there. Standard efficiency boilers, but one year they ran out of money in their energy budget. So look at the energy budget for 2007 and 8. It's around $200,000. 8 and 9, similar kind of $200,000, but 09, 010, and they're up in the $300,000 range. So they ran out of money in their energy budget that year. Here's the Target Finder estimation of where they think they could be if they were better, if they were in the top 25% of peers. So that would be an excellently performing school in comparison to what they are. So the first thing we did was we came in and we looked at their bills, historic bills. On the bottom here with the gas bills, you can see the trends of the monthly gas bills. You can see the heating degree day line, which is what you'd expect it to be using from year to year. The electric is similar. They don't have summer school, so in this year, so you don't see any heating, any cooling in the summertime. But they're following this trend line pretty well. They're a little high on the baseline, summer versus daytime peak, summer versus winter peak. So their constant use is a little high, and these 3 months are troubling. They're sticking way up. So that might be an indication of something that's going to be coming here. And they called us halfway through this year when their gas had been going all summer long. They're using as much gas in the summer here, or 1/3 the amount of gas in the summer as they are in the winter. So just enormous amount of gas use for their reheat of their system in this case. And then all winter long, they're using enormous amounts of gas. And that's mirrored in the electricity. The electricity use is just off the charts. And what we did was we came in, their computer system seemed like everything was fine in the building automation system. It seemed like things were turning off at night. It was scheduled to. But when we ran trends and when we ran temperature sensors in this building as part of a retro commissioning project, we found that that the systems were just staying on 24/7. They weren't turning off like they were supposed to, and the outdoor air loopers were stuck open. The reheat coils were stuck open. So you've got the gas system, which is fighting the cooling system. And truthfully, these rooms were not too bad. The comfort wasn't a huge problem. They were balancing each other, but they were just both going full bore, fighting each other. And we were able to help them reestablish a new contract. They'd run out of their contract with their service company, with their HVAC company. They were no longer under a service contract, and they thought they were saving lots of money doing that. But until it came back to bite them. So they reestablished a contract for service. We're able to fix all the problems that we'd identified and possibly more through their service contract. And then really excellent success story on reduced gas use and reduced electric use. And even their baseline for the electricity is a little bit lower. Now they're staying below that sort of baseline that they were at before. They were a little above it before. This shows that same school in compared to their peers. So this is energy use per square foot, and compared to all the other schools that we'd worked with in the region. 0809, they're here at 120. The bad year, they're up at 200. And then afterwards, they get down into the maybe 80 range. So they're back down to a more typical energy use that you'd expect. With better systems, with a constant volume system, or with an improvement on their constant volume system, maybe ways to reduce the amount of airflow, maybe new boilers, some capital intensive things, but they could get down into this, into their lower energy use range. The other thing that sometimes people ask us about is, how about old schools versus new schools? And I have an old school, so we just really need to rebuild it for energy reasons. Well, I'll mention that these two schools down here, number 2 and 3 over here, are both schools that are turn-of-the-century buildings. They're pretty big, massive buildings, and I think they did have newer windows, so they're pretty airtight in that regard. But their energy use is excellent. They have somebody who's just really on top of what the ventilation requirements are in those buildings. They were performing demand control ventilation, and they were staying on top of it and monitoring that. They were turning the ventilation off at night. They had a pretty big, massive building, so that helps in the heating season. And they had window air conditioners, and when those window air conditioners, when they didn't need them, they were off. And they had a maintenance person go through each night and make sure that those are off, make sure the computers are off. So sometimes it really has to do with that extra diligence and maybe continual commissioning. And that's something beyond what is capable of a 9-to-5 position. And we've seen some districts that have picked up contracts or picked up an employee for nights and weekends to be the energy champion on those nights and weekends, to make sure schedules are correct, to make sure systems are turned off when they're supposed to be off, to make sure computers are off, to make sure ventilation is closed. In fact, put eyes on those dampers to make sure the reheat valves are closed, and alert maintenance teams to when those start failing. Let's go to a map. So one of our first steps would be to look at a map, aerial photograph of a high school. We picked this one for this example we'll walk through today because there's lots of gyms and a big pool and lots of square feet. They were able to give us the defibrillator location map, which is helpful for us to kind of identify different wings at some of these enormous schools. Gym lighting is a very common retrofit in schools, going from old metal halide to new fluorescent, whether that's T8 or T5, or we're starting to see more LED in these high bay spaces, new fixtures. And the major advantage there is instant on, instant off. You don't have to have a restrike time. You can turn these off for the lunch break. You can turn these on occupancy sensors, perhaps, so they're not on in the evening or in the afternoon when nobody's in there. These can be, they can turn off for assemblies and turn right back on. So there's advantages besides even energy benefits here. And they're just nice color as well. Multi-level switching. So there's a hallway that we visited where every other light is off. That's a good thing. But they then let us know that this is what they do during I think passing periods or even like this. So that's excellent. But these actually were the 24/7 operation lights. So these were the emergency lights that are on 24/7, and they don't need that many lights on for emergency egress 24/7. So we were recommending that, possibly you could wire the fixtures to, you could have maybe more consistency if you'd wired every third light to be 1/3 of the lights on in every fixture, or but certainly for the 24/7 operation, taking out some of these onto a different circuit, and not running these in 24/7 operation, but running another circuit, another switch for these, because you don't need to be spending that much energy on these all the time. We get asked a lot about LED T8 retrofits and why there are not incentives for those. And I just posed some possible hurdles to overcome for the industry. I don't think we're quite there yet. In recent years, the costs were $90 per lamp. Maybe they're $20 last year, come down to 10. I've seen some clients experimenting with lamps that are around the $7 range right now. So as that cost comes down, that will help the equation on these. Certainly $90 was exorbitant for the amount of savings that you're going to see. So reduced savings already. We're going from maybe a 32-watt lamp to a 17-watt LED. A lot of the savings was already cut out going from T12 to T8, and so with reduced savings going, from a T8 to an LED. And sometimes people are at a 28-watt T8 already, so that's where that has to balance with the cost coming down to justify with the reduced energy savings. But we've seen people doing these test these on 24-hour lights sometimes. We have a client right now who's looking at some lighting that was on for emergency reasons, and they're looking at doing those. Reliability is another hurdle. Is it going to fail? How reliable is the company that you're getting them from? That was a problem in the past. But then again, now we're starting to see name brand companies with good reputations that are selling them for $10 at Home Depot. So going forward, I think that the cost drops and the reliability improvements will really help, and the industry can reevaluate. There's also sort of a safety question. What happens if you get a short? For instance, what happens if you remove the ballast and you're operating on line voltage? And you could use a dual drive lamp. That's another option. But what if you remove the ballast, and did you label things correctly so that someone doesn't go in and put in a standard T8 back in, and then have line voltage going to a T8 and have a dangerous situation, whether risk of explosion or fire or some sort of issue. So I think these are the issues that the industry is dealing with. We'll continue to evaluate. There just recently, some of the lamps are starting to be DLC listed, Design Lights Consortium listed. In previous years, sometimes there would be a couple lamps that would get on DLC list and then they would come off pretty quickly. So we want to make sure, I think that Illinois Energy Now and DCO want to make sure that these programs, make sense, they're justified, and there aren't safety concerns. So as the industry addresses those concerns, I think we'll see how that moves forward. On the other hand, exterior LEDs are excellent, are an obvious item to retrofit, and parking lot lighting or building wall packs. You have the LEDs up on a tall pole, so the directionality doesn't matter as much as it does in the indoor scenario. So you've got this directionality to these LEDs, and they can be arranged to get a pretty good spread when they're on a tall pole. Savings to 50–60% are pretty typical, and you get a color quality difference, a much better color. This beam spread looks better than what it did in the yellow high pressure sodium lighting. So there's some aspects for maybe safety video. You can see what color things actually are, what color cars are. Maybe these can be put on occupancy sensors in the parking lots, or dimming controls. Maybe they could dim down after 10 p.m. Maybe they can turn off after midnight. Maybe one row would come on automatically, but the rest would stay off. Why do we need a whole parking lot at night lit up in the middle of the night? Maybe just one row is all that we really need. So pools are a big energy user in schools, and we have usually long hours of operation. Lighting is important. So for instance, it's tricky to change these lights. So that's one area where LED lights might be another justified reason there. But we have dehumidification in these spaces. We have the water temperature and the air temperature. The balance of those two is a big concern on how much evaporation is happening. So getting those under control, and looking at, we'll look at variable frequency drives here in a moment. for the pool pumps, but pool covers can really help cut down enormously on evaporation. Pool covers can be expensive, and they can be maintenance, they can be difficult to implement, but the savings that can come out of it really does justify the incredible cost that some of these have. And sometimes they will come out of the ceiling, sometimes they'll be hidden along the edge. So certainly for any renovations you're looking at pool covers is highly recommended. And then dehumidification energy recovery, we'll touch on that too. Here's an example with multiple 15 horsepower pumps running 24/7. They're pushing the water through the sand filters. And when the sand filters get clogged, then you need the full 15 horsepower. But when they're relatively fresh, pretty commonly, we see this butterfly valve that's set to down here is open, up here is closed. And so it's set to maybe 30% open, 40% open. So this is just energy waste going on right here. 24/7, excellent opportunity for a variable frequency drive. And that would fall under the custom program because it's 24/7 operation, it's non-HVAC, and 12 cents a kilowatt hour would be the savings. A project I did recently with this was in the range of $7,000 a year just in savings from just the pool pumps. So it's pretty amazing, the potential savings here. Dehumidification equipment, again, 24-hour operation in corrosive conditions. So valves can fail. Watch out for old hot water valves that are trickling hot water and reheating unnecessarily. Some of these units have hot gas bypass valves, lots of gas bypass valves and valves in these systems that can have difficulty, that require maintenance, but it's justified to keep these units operational based on the energy savings potential on these. So certainly it's pools are an intensive environment, 24/7 operation. You're trying to reduce that 24/7 is another aspect if possible, but corrosive conditions and looking for new equipment, when speccing new equipment, definitely looking at high efficiency equipment, looking at energy recovery, looking at hot gas recovery are all important considerations. Looking towards the boiler side of things, here's some enormous boilers from 1960. These are steam units, and they've updated the burners since 1960. So they have connected controls on the gas and O2. So they're probably 2% better than they would have been otherwise. There are more modern linkageless controls available as well. But I think this school was pretty happy. They were doing daily checks on their burners, and they were pretty on top of things in that regard. But looking at the boiler tune-up program, like we mentioned, looking at new boilers in the future, maybe switching to hot water. Most of the new areas of this building were hot water anyways. They were converting from steam to hot water. So looking at doing hot water boilers would enable you to get into the condensing boiler range, and looking at those high impact natural gas incentives to help pay for these projects. Here's a brief mention of the other end of the spectrum. Here's a small building, it's 20,000 square foot building with a small ancient boiler that's getting cut out, which is a kind of a cool picture. And the new 94% efficient boiler is tiny. It's smaller than my refrigerator. And these black bars in the gas graph here show the energy savings. They save $2,000 in the first year. And they're happy they have a whole new boiler room also. They were able to put a new window in where the old flue stack was. Here's the condensing PVC pipe going out the wall. And they were very happy with this retrofit renovation. Another option for people that have newer boilers, for instance, but newer non-condensing boilers, is to add a smaller condensing boiler called a hybrid boiler or a shoulder boiler for the shoulder seasons, the spring and fall. So days like we're having today, we're in the 40s, so we might be still running the boiler, but it's at really reduced load. A hybrid or a condensing boiler is at peak efficiency on those days with the reduced load and with reduced water temperatures, so making sure to have a stronger outdoor air reset on the reduced water temperatures. These typically normal boilers don't want to go below 140 because they start condensing water and would make a flood in the boiler room. But these condensing boilers can handle that. So if you can isolate the load on those really load days and allow a low water temperature, 120 degree water temperature maybe would be ideal for these. and can have enormous gas savings by running in condensing mode for a majority of the hours of the year. And then you have the big boilers can come on on January, coldest nights in January when you need the full capacity. So it's a really good option to add. And again, these aren't very big. They're modular. They can really fit into tight spaces. Steam trap maintenance was part of the boiler retrofit program. Here's an image of steam trap and the infrared camera that can be a little tricky to use. So it's better to use the ultrasonic sensor where you can really hear the steam traps opening and closing, or you can hear if they're stuck open. And up to 30% failed open is common. And you don't get a comfort complaint when it's failed open either, because everybody stays nice and toasty. You really only get a complaint if it fails closed and nobody gets any heat in their room. But this client was being proactive with maintenance already. But that can be a huge energy saver if you've got open steam traps that are just blowing steam right through. Just an image of the cooling towers at the school, some of the chillers in this room, and newer chillers in some areas, older chillers in other areas, reciprocating chiller that can be upgraded and is on the schedule of maintenance for upgrades in this building. And looking at incentives for that are available. They're not going to pay an enormous amount of that. Part of that has to do with how much energy a chiller in Illinois uses. Schools aren't necessarily open during the summer. They're not using as much cooling as other buildings. So energy savings is related to how much energy you use. Kitchen exhaust hoods. So here's a picture of a kitchen where the hood just keeps going and going and going. And some recommendations might be ventilation reduction on these. So automatic controls that look for smoke and heat sensing to turn the VFD down on those fans and on the makeup air units. So those automated controls, maybe a dishwasher interlock. So why even have the vent running when the dishwasher is off? So that would be a really straightforward control, not a terribly expensive retrofit. Some places have done manual VFD controls. So here's an example of the switches and a small VFD that's set up higher and it's set at 30%, and then they only crank it up when they really need it. So that's another option as well. I'm just going to take a brief mention of this school had such a large renovation, it fell under our new construction incentives. And we'll have a talk next Friday on the new construction program more in depth. But just briefly, this school was renovating, improved lighting, improved envelope, improved HVAC, and they were able to justify that they went beyond code, and they had $9,000 of energy savings by going beyond code, and that cost in the range of $150,000, but they got $30,000 of incentives. So their simple payback is only 3 years. So this is an obvious project to have made those beyond code implementation. This is a few years ago now. The code, at the time, they were 18% beyond code. Now the code is really ratcheted up. So it's getting harder to get these sort of 3 or 4 year paybacks incentives. But it's still an important thing to go beyond code, and the program pushes people. And we're seeing really innovative projects out there and ways for people to go beyond the low bidder and go beyond just the short-sighted, but really invest in the future and invest in a better and more comfortable building. So briefly, in summary, we'll wrap up here. CDAC is in place to help identify cost-effective solutions for energy efficiency for buildings, public sector buildings in Illinois. We're the first stop for Illinois Energy Now questions. We work with private trade allies and private sector partners throughout the state to help implement these changes that we recommend. And lots of examples on our website of further case studies. We have longer versions of school talks. I gave a couple recently to some regional Board of Education meetings, and those are archived on the websites, the videos and the PDFs. This video and PDF will be on the website shortly. But get your buildings involved in these programs: free energy assessments, free retro commissioning, new construction assistance, new construction incentives, and all the Illinois Energy Now incentives that we've been talking about throughout this program. So make sure to check out Illinois Energy, ilenergynow.org, and for incentive information for updates, check out cdac.org for information about our programs, and then details about the Illinois Energy Now program and examples and case studies. And I'd like to thank everybody for your time today. Thank you for joining our webinar, and We look forward to talking with you about your projects and working with you more on your projects in the future. Thank you. Goodbye.